Hey guys, Mr. Long Break here. I hope all is well. Today we're going to be starting our last unit of the year, which is exciting, on equilibrium. And today's notes are all about just an introduction to what equilibrium actually is, or what dynamic equilibrium is. And to start things off, I want to show you something. So in the past with reactions, we've had reactants, and then we've had this little arrow to show yields or produces, and then we have products on the right side of the equation. Well, in equilibrium, we are going to be talking about reactions that can not only go in the forward direction, but can also go in the reverse direction. And not all reactions can do this, but some of them can. Some of these reactions can be at what's called dynamic equilibrium, which is represented by these arrows going in both directions. This one meaning the forward reaction, and this one meaning the reverse reaction. So what is dynamic equilibrium? Dynamic equilibrium is where the reaction has reached a point where the forward reaction, represented by this forward arrow, so H2 and O2 making water, is occurring at the same rate being a very important word here, as the reverse reaction, represented by the arrow going backwards, meaning water is now the reactant making oxygen and hydrogen. Now, if you have not watched the tank demonstration video, I highly suggest it. It's something that we would have done in class if we were in person, but it really helps explain this point. Now, at the submicroscopic level, meaning at the atomic level, at the particle level, the reaction has not stopped. Meaning that this reaction is continuing to go. Even when equilibrium is reached, it is continuing to go. It's just occurring at the same rate. And because it's occurring at the same rate at the macroscopic level, what we see with our eyes, it seems as if nothing is happening. And that's because the amount of reactant and product is not going to change because it's occurring at the same rate. So even though at the submicroscopic level the reaction has not stopped, it's continuing to go, it's going to seem as if it has stopped. Okay, so now let's talk about common misconceptions that students have of a dynamic equilibrium. So everything we're going to talk about here are not characteristics of something that is at dynamic equilibrium. So misconception number one: dynamic equilibrium does not mean the reaction has stopped. And that's what we just talked about up above. It seems at the macroscopic level that the reaction has stopped, but in actuality, at the particle level, products are still making reactants and reactants are still making products. It just seems as if the reaction has stopped because the concentrations or amounts are not changing. Misconception number two, and this is probably the biggest one: it does not mean the amount of reactant equals the amount of product. Meaning if you had a certain amount of reactant, 20 grams, just say a random number, it does not mean at equilibrium you have 20 grams of product. That is not what equilibrium is. Equilibrium is that those reactions are occurring at the same rate, and we'll talk more about what that means as we move through these notes. Now, another fancy word for amount is concentration, and that's going to be really important moving forward. Concentration essentially means the amount of something. And we talked about that in our kinetics unit, actually. And so another way of saying this is does not mean that the concentration of reactant equals the concentration of product, or the amount of reactant does not necessarily equal the amount of product. And last misconception is dynamic equilibrium does not mean that the amount or concentration of reactant and product are changing. A lot of people see the word dynamic and think, okay, this must be changing, and that's not what it means. It does not mean that the amount of reactant and product are changing, and that's because it's occurring at the same rate, both in the forward and reverse direction. So what are the three main characteristics of something or a reaction that is in dynamic equilibrium? So number one, the reaction continues to run. So reactants continue to make products and products continue to make reactants. The reaction continues. The amounts of product and reactant remain constant, meaning they do not change. And that's probably the biggest thing to understand. When something is at equilibrium, it means that the amount of product and the amount of reactant is not going to change. Meaning, let's say I had 10 grams of this and 20 grams of this. If something is at dynamic equilibrium, it means the reaction would continue, but I would continue to have 20 grams of the product and I would continue to have 10 grams of the reactant. They're not equal, but they're staying the same, even though the reaction is continuing to run. And the reason for that is because the forward reaction and reverse reaction are occurring at the same rate. And there's that fancy word rate again. That's why the amount of reactant and product does not change, because those forward and reverse reactions are occurring at the same rate. All right, so now we have two little pictures or analogies to a dynamic equilibrium, and one of them is a very good representation of a dynamic equilibrium. The other one is not. And so quickly in your head, I want you to think about which one of these would be a good representation of equilibrium and which one would be a poor representation. So I'll give you about 5 seconds. So hopefully we came up with this would be a very good representation of a dynamic equilibrium, and this would be a poor representation of something at a dynamic equilibrium. And the main reason why this would be a bad representation is because equilibrium does not mean that the reactants equal your products. And that's what this is showing. It's showing that if this were the reactants and this were the products, that they are the same amount. That is not what equilibrium is, and that's the biggest misconception of equilibrium. What equilibrium is that the forward and reverse reactions are occurring at the same rate. So say this was the forward reaction represented by this ant, and this was the reverse reaction represented by this ant. Well, what's happening is each ant is taking one rock from that pile and transferring it to the other pile. Well, if each ant is transferring one rock at a time to each pile, even though they are taking one rock from those piles, the amount of rocks in each pile is not going to change. And that is because they're each taking one rock and transferring them at the same rate or at the same time. And so this is a good representation because the amount of reactant, which is represented by this pile, and product, which is represented by this pile, is not changing. Notice that they have different amounts in each. Okay, it's not that they're the same amount, it's that they're not going to change. And that's because the forward and reverse reaction are occurring at the same rate. The ants are each transferring one rock at a time. Therefore, the amount of product and reactant is not going to change. Reverse reaction occurring at the same rate. Okay, so that's a little picture or analogy of a good and bad representation of equilibrium to kind of hit home what equilibrium is. Now, you also have to be able to recognize equilibrium on a graph, and there are graphs that show reactions at equilibrium and graphs that show when reactions aren't at equilibrium. And this is something that's really important, especially for those of you moving on to higher level chemistry. So here on the y-axis, we have concentration, and remember another word for that is amount. And let's say that this line right here, this is a solid line, represents the reactant, and this dotted line right here represents the product. So these are the amounts of product right here, and this is the amount of reactant right here. And if you notice on this graph, at the beginning, the reactants start to decrease in their amount or concentration, and then they level out. And the products start to increase over time, and then eventually level out as well. If I were to ask you, recognize or identify where this graph or reaction is at equilibrium, I would have a lot of people say here. That is where they are the same amount or concentration. That does not mean equilibrium. And that's what a lot of students are going to say. Equilibrium is reached when the amount of product and reactant do not change, when they are constant. Well, where are those amounts constant? Right here. That is where the amount of product and the amount of reactant are not changing. When that is the case, that is where dynamic equilibrium is reached, not when they are the same. And so over here, I'm going to say not equilibrium. And over here, I am going to say this is where we are at equilibrium when those are constant. Okay, so based off of this and the tank demonstration, please try your best on the equilibrium practice that is on Schoology, and then we'll end the unit talking about Le Chatelier's principle. I hope all is well. I miss you guys a ton. Hang in there, only a couple more weeks until summer vacation. All right, I'll talk to you soon. Bye.